In the vast expanse that separates two of Indonesia's islands lies an ancient line. It's a mysterious boundary that is both real and not real. Pretty confusing, right? While invisible to the human eye, this line maintains its existence nonetheless. The imaginary line intersects the Lombok Strait between the Indonesian islands of Bali and Lombok to the south, and extends north through the Makassar Strait between Kalimantan and Sulawesi. This inconspicuous yet potent barrier spanning 32 kilometers weaves its way intricately through the entire Malay archipelago, a breathtaking collection of islands that proudly holds the title of the largest of its kind on our planet. This line caused a distinct divide between the fauna of the western islands, with animals largely of Asian origin, and that of the eastern portion where animals were Australasian. On the western side, a vivid collection of animal life unfolds, characterized by the presence of rhinos, elephants, tigers, woodpeckers, and numerous other species that are emblematic of the Asian region. However, crossing over this imperceptible line brings about a profound transformation. Suddenly, the scenery changes, and the islands on the eastern side unveil an entirely different ensemble of ecological characters. Here, one encounters the likes of marsupials, Komodo dragons, cockatoos, honey-eaters, and a host of other unique species that bring an enchanting allure to the landscape. This is being referred to by scientists as a biogeographic boundary. This invisible line represents the captivating meeting point of two profoundly distinct regions of biodiversity. Although there are other biogeographical boundaries in the world, the most discussed and iconic of them all is the Wallace line. Now the question is, why does this invisible line exist? How can something be simultaneously real and imaginary? The Wallace line was named after the British naturalist Alfred Russel Wallace, who sketched it in 1859. He is probably the most famous person that most people have never heard of. He was a 19th century naturalist who, independently of Charles Darwin, discovered the theory of evolution. His notable achievements included pioneering research on the concept of warning coloration in animals. Unlike many prominent scientists and naturalists of his time, Wallace did not come from a wealthy background and faced financial hardships throughout his lifetime. He relied heavily on funding from selling specimens he collected during his travels to collectors in Europe, though his success in this endeavor varied. Wallace documented his adventures meticulously, and his reports of his explorations in Singapore, Indonesia, and Malaysia are regarded by many as the best journals of scientific exploration published in the 19th century. During his travels in the Indonesian archipelago, Wallace collected over 126,000 specimens, several thousand of which were new discoveries to science. The story of how Wallace came up with the idea of the invisible barrier is quite interesting. While battling malaria and confined to his sickbed, he had a revelation, which would forever establish him as the father of biogeography, a field dedicated to studying the distribution of living organisms. During his 8-year voyage, Wallace diligently observed and collected numerous species, traversing from one island to another within the archipelago. It was during his passage from Bali to Lombok that he noticed something intriguing. Despite the narrow strait that separates the islands, the transition in animal life was not gradual, but rather sudden and distinct. In fact, he found the differences between the two regions even more pronounced than those between England and Japan. Birds played a vital role in capturing Wallace's attention. He observed that certain species abundant in Java and Bali, such as the yellow-headed weaver, coppersmith barbet, and Javanese three-toed woodpecker, were entirely absent in Lombok. This abrupt shift extended beyond birds to encompass mammals and even insects. It was as if an invisible barrier separates two entirely different worlds. This revelation led Wallace to find answers to this phenomenon. He came up with the biogeographic line, which was subsequently refined by others in later years. But the line was not merely a reflection of the island's proximity. Surprisingly, some islands on opposite sides of the line were actually closer to each other than certain islands on the same side. The answer to this mystery lies on the influence of geological factors. Wallace proposed that ancient geological events played a crucial role in determining the distribution of living species. His meticulous observations laid the foundation for further exploration into the intricate relationship between geography, geology, and the distribution of life forms. Wallace deduced that the Western islands were once connected to each other and the Asian mainland. This explained how larger animals such as tigers and rhinos could have inhabited those islands, as they are now separated by vast stretches of water too formidable for these species to traverse. Similar reasoning led Wallace to speculate about the islands east of Java and Borneo. Some of these islands were remnants of a former Australian continent. Wallace surmised that throughout the geological transformations, deep waters with strong currents acted as barriers, preventing many species from crossing between the two continents even during periods of lower sea levels. This same phenomenon persists today, as higher sea levels and fragmented continents impede species from crossing over. Even certain flying bird and insect species adhere to the boundaries set by the line, as they are unable to traverse those expansive open ocean stretches. But one crucial idea eluded Wallace and other scientists of the time: plate tectonics. The realization that the planet's surface is not static but dynamic, composed of individual plates that move and collide over immense periods of geological time, was missing from their understanding. Plate tectonics only gained widespread acceptance in the late 1960s, more than half a century after Wallace's passing. The oceanic islands within the Malay archipelago, which are collectively called as Wallacea, stand distinct from the neighboring continental islands, as they were never connected to the larger land masses. These islands served as ecological canvases, awaiting the arrival of various creatures capable of populating them. Primarily, the species that successfully colonized these islands originated from the Australian side, as the Wallace Line acted as a barrier preventing Asian species from migrating eastward. One notable example is the Komodo dragon, a colossal monitor lizard that presently inhabits a few islands in eastern Indonesia. Fossil records indicate their initial appearance in mainland Australia over 3 million years ago during the Pliocene epoch, with their arrival in the Wallacea region occurring around 1 million years ago. Up to the present, the deep waters with strong currents, including the strait between Lombok and Bali, continue to hinder the dispersal of many species across the line, thus preserving the distinct evolutionary histories that contribute to the striking visible differences. Although Wallace's invisible line may not possess a tangible existence, it serves as a testament to how ancient geological events profoundly shaped the diversity and distribution of life in curious and contrasting ways. What are your thoughts about this? Leave a comment and hit that subscribe button. Until the next one.